Hello, everybody, and welcome to another fantastic episode of Truth Wanted. I am your host, as always, Objectively Dan. This is the live call-in show. Happens every single week, Fridays at 7 p.m. Central Time, where me and a special guest talk to people about what people believe and why. And this week's special guest is almost a doctor, Matthew Rahme. Matthew, welcome to the show.
Thank you. I've been looking forward to this for a long time. I'm glad to be here, ready to talk about, science and truth.
Yeah. And so, Matthew Rahme, your YouTube channel is Almost a Doctor. You've appeared on Nervardia's channel as well. Nervardia was a previous guest on this show, and also I was on one of her videos a little recently as well. But you, in particular, have a lot of knowledge in specifically the field of spectroscopy, as well as things related to that. So I was hoping you could start off by telling us a bit about your educational background and what makes you so special.
Well, I mean, my mum always said I was special, but that I think is a different thing. So as you mentioned, my background is kind of in spectroscopy, but I'll get to that in a minute. My channel name, Almost a Doctor, reflects what I'm currently doing. I'm currently doing a PhD in physics. So I am very interested in the scientific process. How do we go from, we think this is going on, to actually figuring out what is going on?
Right.
Spectroscopy is a particular field where we can figure out what's going on around us using some part of the electromagnetic spectrum. Spectroscopy is, I think, translates from the old Greek to using light to investigate. So you can either bombard something with light or look at the light that comes out. And I don't just mean visible light, I mean lots of different ones. So I've got a bit of background with lasers, hence the background for anyone who's watching the show as well. This is a laser I put together. It's a helium neon one. So you have particular colors that come off, but you can also look at things like the sun, figure out what's the sun made of, how hot is the sun. You can look at atoms, you can look at molecules, see what are they doing. When we look at diagrams in science books, in papers, they'll have all the molecules drawn out. How do we know that's the case? And that's kind of where I get to with spectroscopy. More broadly, apart from that, my background is also in chemistry and physics. So that's how I got to my current area of spectroscopy. So I've looked at organic chemistry. I've looked at molecules in medicine, particularly metals. I've done a couple of courses in. Physics covers a lot of things. One of my favorites is astronomy. I'm technically part of an astrophysics group, though my work is actually in environmental monitoring or building detectors for that. So I've kind of got a broad background. I also have a bit of a background in business, but I tend to ignore that one for the most part.
Yeah.
But I've just been interested in science for most of my life.
We're not a super business oriented show, but that other stuff that can stay. We can talk about that. But yeah, obviously you have that physics background, which is something that's pretty valuable for those of us who, like to demonstrate, the quote unquote truth of things using science, because a lot of science, a lot of people say all science kind of boils down to physics at the end of the day. That's a claim people do make, because psychology is just, that's just a study of people, but people are made of atoms, and atoms are part of, you can boil it down to a lot of that stuff, which is funny, but also, super important. And particularly, spectroscopy in particular is important for how we can answer some of the questions that we didn't even think to ask for long periods of time. Like, what is the sun made of? We know that because of the science of spectroscopy, along with other things, but that in particular is how we know, and also helps us know how to figure out the dates of certain materials and stuff as well. And so, it's important when we talk about like young Earth creationist stuff, we know these materials and where they come from and how all this kind of works. And naturally, when you go into a field like this that involves a lot of math and a lot of physics, there's going to be a lot of cranks and stuff out there as well that are going to try to completely derail everything the community has been doing for a long time. So part of the reason why we wanted to talk to you today was also to talk about what are some of the kookier ideas out there. A lot of that's what we hear right now is, of course, the 5G towers and stuff. That's what I think of, people who don't understand how radio waves work and stuff. I mean, even that goes back to like microwave myths and stuff, right? People think that when you're cooking food in your microwave, you're actually radiating your food, like it becomes radioactive, which is not what that means. That's not how that works. So I was hoping you could tell us a little bit about that. Like, what's your intersection there when we talk about this field?
Well, I've particularly over the last couple of years that I've started teaching, I've also got interested in how to communicate science. And so that's brought me in contact with a lot of these. So and a lot of it is that there's just an enormous mountain of misinformation out there, but it's nothing new. And so I also have an interest in how do you tackle these problems? How do you tell people what's actually going on? Because one of the things with science, there's a few major misnomers, but one of the first ones that comes to mind is that science itself is boring. It's slow and it's tedious, but that's never how it's portrayed. The findings, on the other hand, are fascinating. Mm-hmm. What you can do with it is amazing. But to go through and be like, this is how we started at this information, and went through all the way and came back to this is where we are now, is not a quick process. Well, we always get presented with breakthroughs, but that's not how it goes. So, for example, with the 5G towers, 5G in general, a lot of that, is a misunderstanding of what radiation is, how it works. And so sometimes it's just a matter of trying to present that. So, for example, the 5G, people talk about radiation. The word radiation has a very negative kind of connotation with it. Whereas to someone who's studied science or someone who's interested and has looked at it, radiation can mean a lot of things. So you can be talking about nuclear radiation, like what would happen if you fell into a nuclear reactor, for example. But you could be talking about light. So if I'm talking about the lights that I've got shining on me, that's radiation as well. And in fact, the radiation coming off the light here, each of those photons has more energy than the photons coming off a 5G tower. The light here has more potential to do me damage than a 5G tower, which those sorts of things. And with the microwave, all it does is heat things up.
Yeah.
It's not going to, so we always get scared about, what if the radiation comes out to me? Well, if it does, it's going to heat you up. And that's the first thing you'd feel. But we have ways of blocking that. That's why you have the little mesh with all the holes in it. Mm-hmm. So that the photons, because the wavelength is too big, can't fit through those holes. That's why you can actually see into a microwave without a problem. And so it comes back to how do you communicate this to people? And I've always had an interest in that.
Yeah, you've seen like they have these things you can buy, like these cages for people's routers to supposedly block out the radiation that comes with the Wi-Fi routers in people's houses. Like they actually have that, which is like, defeats the whole purpose of having a Wi-Fi router in the first place. Like it's supposed to send stuff out and receive stuff. So I don't know. People get really confused about the science of a lot of this stuff. And this sad thing is, of course, there have been more than one 5G towers like attacked now because people really think this in particular is doing harm. But just the science of this stuff in general is really lost on people. So I guess I'm wondering, like, what's your ideas on how to talk to more people about the nitty gritties on this kind of stuff? Because I mean, I can tell you, I'm a layperson and I can read what I see in a book or on the internet, and maybe I can do that effectively, but I haven't studied this stuff for years, so I don't know the ins and outs. So if I see somebody throwing a bunch of stuff at me, I can only refer to people like yourself. So what's the easiest way to, talk to people about these sort of highfalutin scientific concepts? What's your strategy there?
I think the best strategy is kind of multi-pronged, because people will listen to different people on different platforms. So I love shows like this. This is one way of doing it. Other ones, like my YouTube channel, I try and make shorter videos that kind of have interesting twists to them to give people a different way of thinking. Sometimes it's a matter of going on more, public, say, like TV broadcasting stations. So I guess it really depends on the issue, but the main thing that has to happen is just repetition. It is so easy to come up with pseudoscience, but it is very hard to communicate real science, because there is a big disconnect between that scientific process and then how it gets presented. Because I said, if you follow everything through in a proper scientific paper, it's fairly boring on the face of it until you actually get into it, until you realize what the implications of those are. And so, yeah, I think it's up to people who do have a science background to join with people who are just better at, good at communicating, platforms like this, news media I've already mentioned, and just saying what they do, being like, here's what it actually is. And that's why I like the back and forward, because then it allows people who, it's like, oh, I get a say in this as well. This is what I think. And then you be like, okay, that's very interesting, but this is what we have to correct. Or actually, no, you got that correct. And like anyone can do science. It just takes a lot of time. And so hopefully today we can get some good information. But if there was one answer, if there was one way of fixing all the misinformation out there, I wish I knew it.
Yeah, I wish I knew it too. Now, I need your comments on something here. Our U.S. Representative Marjorie Taylor Greene said that the California wildfires were started by lasers. So I was just wondering, do you have any commentary on that?
I have a bit I can say on that. So
Okay.
I was looking at one of the comments she made, and it was I think she was thinking that we were reflecting sun's light down and occasionally missing these like solar batteries that were absorbing the energy, and it was starting the fires. That was kind of the interpretation I got. If you were reflecting the sun rays down, one, it wouldn't be a laser. Lasers are a very specific definition, and they have one color and generally also coherent for anyone who wants to look that up. It just means the wavelengths all line up very nicely. It's very useful in research. I won't get too much into that. The other thing people seem to not also know with lasers is that the beam, like most light, will spread out as it travels. So if you're trying to target something from space, by the time the laser reaches the Earth, it's going to be covering quite a wide area.
Yeah.
So you also see this when people, like with flat earthers who fire lasers over a long distance, like, I can still detect the laser, the Earth's not curved, and they forget that the laser will actually widen as it spreads.
Right? It disperses over time, and that's why, like, yeah, we do send out like radio signals and television signals out in the space, but they get so spread out, that the strength of these signals, isn't the same over time. Yeah, I think I heard about that. Yeah.
And lasers are also a very inefficient energy source. If you're going to make a weapon, if you're going to make something out of it that could do this, you wouldn't do a laser. It's just the worst way to go about it. Lasers have very specific uses. And yes, they are kind of used in the military, but as just a flat up weapon to start bushfires or to send energy from space to here, not a very good or efficient method.
Jewish space lasers, probably not the starter of the California wildfires. Is that your take?
As someone coming from the non-existent Australia where we get bushfires all the time, I have never seen a laser start a fire.
All right. I just want you on record, Matthew. I just want to know if this is the truth. And also, apparently, all the Austin Powers movies are complete lies at this point. Which
I made a video on why you can't put lasers on sharks for anyone who wants to go check that out. But yeah, as I said, lasers don't make very good weapons. They're just not how you do it. You can use them to maybe target a couple of incoming missiles, but or for aiming. But in terms of making space weapons, I can think of a million better ways to start a fire.
Yeah. Well, I don't know. I mean, if I had access to a giant space laser, I mean, I don't know. I don't know what I would try to do. I don't know if I'd try to start a fire, but I would want to see, maybe what we could do with it, right? So let's go back a second to the spectroscopy stuff, because I think this stuff's pretty interesting. We were kind of talking a little bit before the show. My first exposure to spectroscopy was in college. I had an astronomy course where we had to do these calculations on the temperature of different stars, and then based on their distance and their temperature, kind of figure out how old they were and stuff. I think it was all very complicated, and I didn't do very well on that particular part. But it was an early key for me in understanding, like, oh, this is how we know this stuff. Because when you grow up and you hear someone say, oh yeah, the Earth is such and such years old, and the sun is such and such years old, and this planet such and such years old. How the heck do they figure that out? You're like, were you there? Like people just it seems like you can just make these numbers up if you don't actually understand the processes and stuff. And so, my growing up and learning about the world and the experiences of scientists who are smarter than me who have been figuring this out has been like, oh wow, it's been years and years of studying these subjects that we figured this stuff out. It's not just tradition. It's not just one scientist on high giving information to others. It's actually very diligent work, and a lot of times it's very boring work, writing papers and recording observations and stuff like that. And I think this stuff kind of gets lost again on the general population. I mean, you can go to college and still not know a lot of this stuff if you don't, take too many classes in the sciences. And so I don't even think a college education is always enough. I think you do need specific kinds of, classes in the sciences to figure this stuff out. So I don't know, like when I talk to young Earth creationists, for example, and we talk about how we know about the materials of the sun or the moon and stuff like that, like a lot of times they don't even realize how we know this stuff, because they don't know, hey, there's lots of people that have been trying to figure this out for a long time. Or maybe they just, I don't know, they just heard something one time and that's how they get their knowledge. But yeah, I mean, like, what do you think about that? Knowing that you've been studying this for a while, there's these processes, but like a lot of people just don't know what you do. Is that frustrating? Or
I see it more as an opportunity for me to get out and tell them what I do. If I can try and get people to listen, because the findings, as I said, are very fascinating. And I love how you brought up the temperature of the sun, temperature of stars one, because a lot of things in astronomy have to be approximated because we're only observing from our one tiny little dot in the universe. And it also is where you get the kind of marriage of theoretical science with kind of practical observations. There's a lot of people who like say, oh, but it's only theoretical, or it's, you can't always trust, like the theoretical physics, for example. But there's no real separation. You don't get that kind of separation in the different science fields. Like there's no distinct line between chemistry and physics. It's a very broad kind of overlap. And so you have to take all these different pieces of information that have been developed sometimes over the last 400 years to get to what we know now. So for the example with the temperature one, it's one of the few cases where we can be almost spot on about what we know about what's going on. So if you want to figure out the temperature, it's actually balancing different equations, and you can get a very, very nice mathematical prediction for what the temperature is. And then you can just look at the color of the sun. You can look at the colors that have been emitted out of certain elements. You can figure out not only the temperature it need to be to make that exact spectra, but you can also figure out the makeup, those different elements that are there. What are their concentrations? Because if you figure out a few things, you can then go through and learn the rest. And so, that's a very good example, because I remember in our class, they said, all right, here's the theory. Now we want you to go and do some calculations. We want you to run these, some computational experiments. And then later on, we had to do it for more real elements. Then we had to do this. Well, this is a solar spectra. So what does this say about it? So when you go through, science, particularly at a senior level, a lot of it is, even from kind of first year, college level, university level and above, it's not just here's the theory. It's here's the theory. Now there's a lab. I want you to go check it.
Yeah.
And
you have to do it yourself. Yeah. You get to. Yeah. That was my experience too. That was my experience when I took one of these classes. Like it was never just here's what this book says. It's look, we can do this in a lab. We can show you all the techniques. If I was taking that kind of course, but that course in particular, we did have lab work for that kind of stuff. So yeah, it is fascinating. It's fascinating, but it's also sad to me because I get to have conversations with folks like you on this show, and I can hear all day about all the amazing stuff that the community of smart people have figured out that I get to just talk about on this show. And it's like, well, and everybody around me just doesn't either has no interest or just doesn't realize like, hey, there's so many answers to these questions people have. We don't have to guess as much as people make it out like we do, you know. But I don't know. People are not trusting science as much these days. It seems like people are getting a little weary, and there's a lot of reasons why. We might go into that later because we were talking about that too, about the trust in some of our institutions. But we do have some calls, Matthew. So I think we should go ahead and get to that if you're ready.
Oh, I'm definitely ready.
All right, cool. Well, before we get to calls, I have to thank our special patron of the week. That's right, folks. Every single week we have a special patron that we'd like to thank. And if the crew has the one for this week, they can go ahead and let me know. We didn't actually do a check for it beforehand. But once we get that out there, I will shout out the name. Here we go. We got it in the group here. And the patron of the week is Maxwell. Thank you, Maxwell, for donating to the group. There it is, Maxwell Carlisle. Thank you, thank you, thank you. Sorry about that, folks. Thanks so much. You can donate on patreon.com/truthwanted. All of the money that goes to the Patreon helps get this show happening. For example, you may have noticed I am using my personal Sennheiser headphones because I accidentally broke the other ones, and so now we got to get new ones. So those of you who donate to the show are helping get new equipment like that because of clumsy folks like me. So thank you guys so much for making this show happen.